SwayamPrabha. Digital India. Educated India.
So, friends, in the subject of operations and production management, we are talking about a unit that is demand forecasting. In our previous session, we talked about the importance of demand forecasting. It is very important for all production planning related issues, whether we are selecting the location for the purpose of layout, or rather when we are selecting the product or services to in which we want to do our business. So, all this depends upon the long term study decisions, long term time horizon based forecasting. Also, the forecasting is important for operational level decisions like inventory, purchases, vendor development, as well as production plans and dispatching also. So, all these issues, the important input information for production planning, for production and operations management is demand forecasting. We studied the technique of time series analysis, and we found that time series analysis is very good for short term forecast. If you want to forecast for next week, next month, it is very good. But if the horizon is slightly longer, or there may be some external factors entering into your system, which is not captured in the previous time series data, then there is a limitation of the time series method, that they may not be able to capture those external factors. These external factors which are independent in nature, we are having another set of techniques which is called causal model or regression model. There can be a simple linear regression, there can be complex regression models also, but here in our course we are studying only linear regression model, that too with one independent variable only, but there may be a multi regression model where more than one independent variable is there. The main limitation, as I said, of the time series model is that they are good to carry forward the past demand if the scenario remains same. If the external and internal environment remains same, then time series models are very good. But if there are some changes in the external or internal environment, those changes will not be captured by the time series model. They have to be independently captured. After doing the time series forecasting, then we can superimpose those factors, or we can have causal models where we can built in within the model those independent variables. So, in this session we are talking about causal models, regression models. They are required when the demand of the product or service depends upon the advertising budget. There can be a case where we say that the demand of the product is proportionate or to depends upon the advertising budget. So, in that case, if we are having the previous period's data of demand as well as the advertising budgets in the form of we can say that advertising budget and demand. Let us say for certain periods, if we are having this data, time periods. In period 1, advertising budget was let us say 1.5 lakh and demand was let us say 70 lakhs. In period 2, let us say advertising budget was 0.8 lakhs and demand was let us say 50 lakhs. In period T, advertising budget was 1.2 lakhs and demand was let us say 72 lakhs. So, like this, if we are having some data of let us say 8 to 10 periods, more the data better is the modeling, but at least if I am having around 10 points this, then I can develop the model of a regression, where I say that my independent advertising budget is independent, which I am deciding, and based on that the demand is dependent on that. So, x is called independent variable, x is called independent variable, and y is called dependent variable. So, in this case we are developing a model like this, y is equal to a plus b x. We are saying that or we can, if you draw the plot this graph, we may get a graph of this nature x and y. So, we may get this kind of a demand graph. If my, even if there is no advertising budget, there is some sales, and then as the advertising budget increases, the demand increases. So, that is kind of model. It may not be exactly fitting, that points may be lying it, and within that we use the method of least square. We design the line in such a manner, least square method we use. We design this regression line which is passing through this point, and the deviation, the square of the deviation from the line is the minimum. Sum of the deviations from the regression line of the actual point is minimum. So, that is how we can see that if the advertising budget is deciding the demand of the product. There may be another situation also, in which case the advertising that we decide that my advertising budget is going to be about 10% of the actual sales. Sales and advertising budget. So, if you want to predict what is going to be my advertising budget for the coming period, I am having data of a few periods. I am saying that if the sales is 50 lakhs, I will spend 1 lakh on the advertising. If the sales is 60 lakhs, I will spend 1.2 lakhs. In the previous period, sale was 65 lakhs and advertising budget was 1.1 lakh. As sales was 90 lakhs and advertising budget was 1.3 lakhs, like this. If I am having some past data, in that case x is my independent variable and advertising budget depends upon my sales. So, advertising budget is some proportion of the sales. So, there can be model in this manner also. So, we have to be very careful in deciding in finding out which is my independent variable and which is the variable which is of my concern, for which I want to make a forecast, that is my dependent variable. Like here in this case, I want to know what is going to be my budget, advertising budget for 5th period if my sales is 80 lakhs. If my sales is 80 lakh, what is going to be my advertising budget? So, in that way there can be a situation. This particular thing can be further, there can be time lag also, like there are periods we say that if there is a 50 lakh sales, then in the next period I will spend the data is not directly connected with this sales advertising budget. So, advertising budget is connected with the previous period sale. The advertising budget of period 2 will be related to the sales of the previous period, or if it is 60 lakhs, then it is 1.2 lakhs. If it is so, in that case I have to develop the regression model, where I will take for this y, I will take this as a x. So, there can be a time lag between the happening of the event x and happening of the event y. So, we have to develop such kind of a model. So, there can be even lag of 2 periods also, or 3 periods also in some cases. Some phenomena has happened, its impact will come after some time. So, but that effect is dependent upon that particular phenomena with certain time lag. So, similarly, the demand of car depends upon the economic growth. If there is a GDP growth, if there is economic activity is good, there are certain demand of certain products, demand of houses, demand of cars, demand of white goods, and many more such kind of items, which depends upon if there is a economic growth, if the more job opportunities are there, more employment is there, then you will find the demand of certain item depends upon the economic growth of the country, or at a macro level you can see that. So, in that case also what we have to do, our variable x is economic growth. We will see the data of previous few periods and then my demand of cars. So, in that manner we can develop the model y is equal to a plus b x. Okay. So, in this way we can develop the model. There can be another case at a lower level. Demand of the canteen items depends upon the number of students in the university, in the institute. So, if a canteen fellow has to bid for a particular canteen space in a this thing, so he can collect the data from certain other institutes, canteens, etc. He will find that in institute 1, the number of students are, let us say 2000, and the sales of canteen, it is let us say 25 lakhs in per month, or yes, let us say per month. In institute 2, the number of students are 1500 and sales is 20 lakhs per month. In institute 3, you are having let us say number of student 3000 and sale is let us say 30 lakhs, like this. So, you are having the data of certain institutes, and then you said that this in this particular institute where you are trying to bid for it, let us say institute K, the number of students are let us say 2500, and then you are saying how much is the expected sales in the canteen. So, in that manner you can find out what is the expected demand, expected sales in that canteen, and you know your profitability of 20%, 30% of the total revenue, and based on that you can decide how much I should pay as a license fee for this particular canteen, or hiring charges or rent of this particular canteen for hiring that facility. Similarly, sales of depot depends upon the industry sale. Let us say take the case of televisions or some white goods or refrigerators or air conditioners or some product, or it can be cars also. We can say that overall sector sale, we can say that industry sale independent variable, and at your depot, at your sales outlet, or it can be for a particular city, it can be for a sales outlet, it can be one outlet or it can be group of outlets in that particular city, in that particular district, or under the command of a particular sales manager, sales team, or like that. Then you can say that okay, if the industry sales is let us say 150 crores, then depot sale is something let us say 5 lakhs. If the industry sales is some number, based on that there is a depot sale. So, you are having some data of the past, and based on that if projections are there in the coming months, the depot sale is going to be 250 crores, then you can very well forecast what is going to be the sales of your outlet at your depot. Similarly, the production cost depends upon the number of units produced. We know that there is a relationship of a fixed cost and variable cost, and based on that also, otherwise by taking the empirical data also, we know that if number of units produced and production cost, unit produced x, production cost y. The production cost depends upon number of units produced. So, based on that we can make out in the past 6 months, 8 months, every month you produce certain number of units, and you know what is your production cost from the costing data. And based on that you are having some data of last 10 periods, you are having this data, and based on that if you know that if 11 months you have a target of let us say producing let us say target of producing 25,000 items, then you can very well forecast what is going to be the production cost. Rather than using the costing data and other thing, we can use a very simple regression model to find out how much is going to be the cost of production per unit in this case. So, these are some of the examples of causal model where our demand of our item or the independent variable affects the dependent variable. Moving forward, this is the model which we I have written here. The y the independent variable depends upon a plus b x. From this we can calculate the value of a and b. If we are having some data, we can like I have drawn here advertising budget and sales in crores. If my independent variable x is advertising budget and sales is my dependent variable. So, we can find out. So, what is required is I should have some set of data, and based on that, from that we will calculate the average of y, average of x and some other numbers, and based on that we will develop. We will see with the help of one example. Let us take this one example, where we are having industry sales in billion, variable x, and store sales in 1000, variable y. Okay. So, two variables are there, one is independent variable, that is industry sales, and then there is a dependent variable, that is store sales. Store sales is in 1000, industry sales is in billion. It can be any currency, it can be in dollars, can be we can consider in rupees also, any unit we can consider. For the understanding of the method, we can do that. And now, our first thing is y is equal to a plus b x, that is the model which we are going to find out, and first task is to calculate the value of b, and value of the b, the formula is very simple, summation of x into y. So, I will do x into y in this particular column, I am multiplying x with y and I am writing the numbers here, and then the summation of all. So, 1189 sigma x y is equal to 1189. Then I will find out the mean of y. I am having y 181 total, and the mean is 18 point, average of this is 18.1. Then I will take the mean of x also, mean of x is in my case is 6.1. Then I will calculate another thing which is x square. So, this is x square, we will calculate here, we are squaring this x, square of 2, square of 4, square of 4, and like this, and my total turns out to sigma x square is 419, sigma x square is 419. Similarly, we will calculate the mean, x is already there with the 6.1. So, we will take the square. Now, putting all these numbers in this formula, what we are getting value of b 1189, that is sigma x y minus n. There are 10 observations here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 observations we are having. So, n is 10, y dash is x dash is 6.1, y dash is 18.1, and divided by x square, that is 419 minus 10 into 6 x square, that is 6.1 into 6.1. Doing that, I am getting a value of y as 1.81. And from this value of a we can calculate by using this relationship. A is equal to y bar is 18.1 minus b x bar. B is 1.81 we have calculated, and x bar is 6.1. From this we will get a is equal to 7.6. So, my regression model is y is equal to 7.06 plus 1.81 x, like this. So, I can use this. Now, in let us say for the 11th period, I came to know that industry sales is going to be let us say 5 billion. Industry sales is going to be 5 billion. So, what is going to be my depot sale, my store sale? So, if x is equal to 5 billion, then y is equal to 7.06 plus 1.81 into 5. So, this will be 5 9. So, there is a chances of 17,110 units you are going to sell. Around 17,000 is expected to be the sales at your depot. So, this is how we can forecast the demand at a particular depot based on the industry sales. Same thing we can do for automobile or some any product we can find out, or it can be in the same way. If my independent variable is canteen, if my x is number of students in thousands, and this is my sale of canteen in, let us say this is in lakhs per annum. Okay. So, if there are 2000 students in this college, there is going to be the sale of 9 lakhs. If there are 4000 students in the institute, sales is going to be 13 lakhs. So, in this I am having data of 10 institutes in the city. From this I am having this data. Now, there is another canteen which is on offer available to the for bidding. So, I know that the number of students there are 5000. So, based on this I can say that this is my expected sales in that particular canteen environment. So, like this. So, any such kind of forecast we can do with the help of having the information about the independent variable. Moving forward. So, based on this we get this data and we can plot it also here on the graph. Now, this is my regression line which we have got in the previous slide, that is y is equal to 7.06. So, this is a line for y is equal to 7.06 plus 1.81 plus 1.81 x. So, like this, and these are the actual values of y. So, this is the deviation, this is the deviation from this, that is the least square method we use, and we found that the line is passing through these points, but many points are scattered around this line, and this is the best fit of this line for this set of data. So, that is how we can develop the regression model. As I said, if there is a demand of 5 billion of the industry, based on that we will get a data about that how much is going to be the expected sales at my store. So, we can do this graphical method also to find out the expected sales at my store depending upon the demand of industries. If I am having some forecast of the industry sales, industry data, I can find out what is going to be the expected forecasted sales at my depot. Based on that, I can do the inventory planning, I can place the orders on the dealer, and I can do my subsequent planning based on that. Or if it is a manufacturing case, you are one of the company manufacturing this, like just like if we say the car sales in the country and a particular brand is so based on that they will gear up their manufacturing facilities. If they found and they can do their planning, how much manpower is required, how much inventory resources are required, raw materials are required. So, you can make your purchases and other inputs which are required for manufacturing, you can plan for that. So, it can be used, the information can be used for the purpose of purchasing, the forecast can be used for various types of decisions. It can be for operational decisions or it can be for other long term decisions also. Based on that, you can take a call on this. Now, question arises, can we apply this regression model for any set of data? Can we apply this regression model any set of data, or there is some prerequisites for that? Obviously, if there is no correlation between the two parameters. So, before applying the regression model, we should know that yes, these two parameters are dependent on each other, or there is y which is dependent on x. If the parameters are not dependent on some other parameter, then obviously we cannot apply the regression model. Though mathematically we can do that, there is no problem. Mathematically we can do that, there is no problem, but technically you should not be doing it. Let us take the example here. If there are parameter x and y which are totally unconnected, you may say that sales in the canteen and some parameter and sales of car, sales of canteen, and you want to forecast the sales of canteen based on sales of car. Obviously, these two parameters are not having any relationship with each other, but if you collect the data of previous few periods, and you will find some regression model is coming in between also. And based on that, if you are making a forecast, obviously it is going to be a wrong application, you should not be doing it. So, first is at a conceptual level, I should know that yes, there is a relationship, there is a dependency of my product on certain independent variables. That is first, which if you are a domain expert, if you are working in that particular area, you know that which are the factors which are responsible, which are governing the demand of your product. So, that is first, which is at a knowledge level, which is at a subjective parameter, but mathematically also we can see that we should apply the regression model only if there is a good coefficient of determination is there. Or first let us see standard error of estimate. I will, after applying this, I will calculate what is the standard error of the estimate. If the standard error of estimate is more than 10%, that means this is not a good measure of estimating it. Before using the regression model, I must calculate the standard error of estimate. What is the error in that? Or even if I am using it, I am aware that yes, there is a 20% error is possible. So, I should not be too much depending upon the forecast. I can take it as for a reference purpose, but I know that there can be error in the estimation. So, that way it is not a good measure. Second important thing which we can take is or before applying, I can check the correlation also. If there is a poor correlation between the two parameters, obviously I should not be applying the regression model. Another is the coefficient of determination. How much variability in y is explained by x? If this coefficient of determination r is very good, 0.9, that means 90% of the variation in y is explained by independent factor x. On the other hand, if this coefficient of determination r is very small, let us say 0.4, then only 40% variation of y is explained by x. So, that way we are knowing beforehand that how much variation in y is accountable to x. In case of it is very high value, I can use it. In case this value is small, then I may try to find out some other variable also, a plus b x. So, I will try to find out some other independent variable, and then it can be multiple regression rather than a simple regression. I can work out other independent variables also. So, that my coefficient of determination is fairly good, more than 0.7, 0. Higher the better. So, so that is very important. Before using the model, I should be knowing how much is the reliability of this model, whether it is truly determining the my independent dependent variable, or it is only 40% of the variation of y is explained by the independent variable. If that is the case, I can work out I should try to include some more independent variables in my regression analysis. Another thing which is important is so far when we are developing these models, we were talking about the linear regression only. Model is y is equal to a plus b x. So, what we are saying is the relationship between the variable is linear in nature, but there may be a cases where we can have a quadratic relation also, y is equal to a plus b x square. So, the relationship between the two variable can be of this nature, or there can be other nature also of these variables can be there. It can be any shape. So, there we are only talking about here linear regression only, but that is the very beginning of the regression or causal model. But in the case of demand forecast in real if you know one or two important parameters where it is linearly related. So, we can use for that purpose, but obviously for better purpose, for more rigorous purpose, for better decision making, we should identify more number of independent variables and also see that a relation is linear or it is something different from the linear. So, that also we should keep in mind. Now, after talking about the quantitative techniques, that is brainstorming, that is regression, that is causal, that is time series models, and the regression models. Now, let us look at the qualitative techniques. We said that qualitative techniques are useful for strategic forecast, where the past data is not available, for strategic decisions, where the past data is not available. We use the qualitative techniques, which is more based on the knowledge of the experts. This is based on the knowledge of the expert rather than the data, whereas quantitative techniques are dependent on the past data. Here we are having the knowledge of experts, which will help us in deciding, in finding out what is going to be the future demand of certain product, certain technology, or certain field of maybe a service. You want to set up some recreational facilities, or maybe some old age home, or maybe some facility for meditation, or some high end facility for yoga, etc. also, which is required in these days. People want to distress themselves by visiting those places, or it can be some tourist place. So, for that, since past data is not available, this is new phenomena which is coming in India. So, there we may not have some past data available, and we do not know the independent variables also, which will influence this particular the demand of this. Maybe after 10 years or 20 years we are having data, and based on that we can work out. So, but at present we do not have any past data. So, time series is not available. At the same time, we are having very limited knowledge about the independent variables, which will influence the demand of such kind of facilities. So, in that case we have to depend upon the experts only. So, we can go to the experts and we can find out what is their view about this, and in the process we will first find out some independent variables, and later on after some time, after some years, a few years, we will get to know the time series also, and based on that then we will start making use of the quantitative techniques for forecasting. So, in this series we are having certain techniques available with us, very simple techniques and highly useful. They are some techniques are coming from other domains also, like idea engineering and knowledge management also, but here we are using it these techniques for the purpose of demand forecasting. So, friends, let us see that techniques, this one we, though there are so many such techniques, but here for our discussion we are taking 4 techniques. One is brainstorming, second is market survey, third is Delphi, and fourth is historical analogy and life cycle analysis. So, let us understand these 4 qualitative techniques also, which are important for long term decisions, strategic decisions, where the past data is not available. Brainstorming is for a situation where a group of people meet to generate new ideas and solutions around a specific domain of interest. By removing inhibitions, people are able to think more freely, and they suggest as many spontaneous new ideas as possible. All the ideas are noted down without criticism, and the brainstorming session, and after the brainstorming session the ideas are evaluated. So, in brainstorming what we do, the process is very simple. What we do in brainstorming is, we identify the experts in that particular domain, we identify the experts in that particular domain. Experts can be from technology side, like if today environment we can say what is going to be the demand of e-vehicles. We want to forecast the demand of e-vehicles, companies want to enter into e-vehicles, battery vehicles, electric vehicles. So, they want to find out, they want to forecast. No past data is available in other countries also, it is still at a evolving stage, and technology is also not very mature. Battery technology is not very mature still. There are expectations that more innovations will come and the cost of battery will come down. So, we can take some experts from the technology area, we can take some experts from the policy area, because government is giving certain discount, incentives, etc. also. We can take some people from the society also, from the social organizations also. We can take some experts from the industry, automobile industry. automobile industry we can take. We can take some experts from the banking sector, because they are providing the financial support in purchasing or some other support. We can also take the people who are going to develop the infrastructure for that. We can take infrastructure people who will develop the charging stations. So, some experts may come from this. Okay. So, in that manner we will select around 40 to 50 experts related to that particular topic, and they are coming from different domains. Then we will invite them at one place, in one committee room. We invite them at one committee room, in some committee conference room, and then we raise there is a moderator. There is a moderator or industry person who is interested in knowing, or there may be a industry association who is conducting this exercise to find out the growth of e-vehicles. There may be automobile association or something who are doing this exercise. So, after this, now comes the fine points of brainstorming. After setting the stage for the brainstorming session by having the experts, by having the venue, by having the moderator. Moderator will raise a query and will seek the ideas from the audience, from the expert. He may say that, in your opinion, what is going to be the demand of electric vehicles in next 2 years? You can start with the shorter time horizon, or let us say for 2 years. Then people will say that the demand is expected to be certain numbers, and then they will also give the idea why they are thinking so. Or you can say that what are the factors which will enhance the demand of electric vehicles in India. So, what are the factors which will enhance the demand of electric vehicles in India. So, all experts will give their idea, and what is required by the moderator to keep on writing as it is without any discussion. Whatsoever a idea is coming, he should write them as it is, and he should not raise queries or anything. In the first flow, we should allow the free flow of idea. There are two things: the idea may not be very good, free flow of ideas. The idea may not be very good given by individual, but another person can take a clue from that and further improve the idea, or a third person can combine 2-3 ideas which are given by the previous experts, and based on that develop some workable idea. Second, if we start analyzing the idea at this stage itself, that will suppress the creativity. Then people will start thinking before giving the idea. So, in the first case, we will allow the speakers, allow the expert to speak out, and we do not analyze, we do not question, we do not seek the clarifications. Whatsoever statement without any editing, we keep on writing on the board as it is, whatsoever is said by a expert. Once these ideas are listed, maybe to the tune of 50 to 100 such ideas are listed, each one is telling 1 or 2 ideas or more than that. Once these 100 such ideas are listed, then we will go to the second phase. So, this is step 1, where we are listing the ideas. Then in the step 2, now we will ask the expert to explain what they want to say about their idea, and in the process you will find that these ideas are getting combined. These ideas, some ideas are we are finding not workable. When it is further detailing is done, we found that it is not workable, and from that we may left with 10 ideas or something like that. So, then we can further combine and come to some kind of a decision related to that. Based on these concepts, then we can say that how these are going to in the second question, in the second round, we can say that how these ideas are, based on these ideas, what is going to be the demand in next 2 years, in next 2 years, next 5 years, next 10 years, like that. Further discussion can be there, or before taking the demand, you can say that what are the steps which need to be taken by the government in terms of promoting the electric vehicles, in terms of policy interventions in that, in terms of facilitating the manufacturing of that in that. So, based on that also, so that first you develop the background of this, so that all experts are having the knowledge from different domains also, and then based on that a collective wisdom can prevail, and based on that they can give the idea about the what is the expected demand in coming years. Obviously, this is a long term projection, 2 years, 5 years, 10 years. We will not talk about in next 3 months, 6 months or 2 months. We will talk 2 years, 5 years, 10 years or 20 years also. So, that kind of a planning horizon we can keep. There may be certain person from the petroleum industry also, they know how this prices and other things are going to be. Petroleum industry can be there. So, there can be some environmental from the environment side also you can have, because these electric vehicles are clean vehicles. So, maybe they say that if the government policy is coming with respect to pollution and other things, air pollution and other things, then obviously that will promote the electric vehicles. So, in that sense this brainstorming session is very, very useful for certain technologies, for certain products for which we do not have the past data, previous data is not available. So, in those cases we can use this brainstorming method. Now, coming to the market survey, every day we are witnessing some kind of a questionnaire is given to us, or it can be panel survey, a questionnaire based survey, panel based survey, or trials of test and trials of the products, etc. You have a product, 3-4 different types of product you have prepared, and you want to know how the people are going to like these products, and what based on that you can estimate the demand of the product, or you can develop a questionnaire and you can seek the feedback from various people. The advantage of this is you need not to identify the experts, and you need not to invite them at one single place. The major limitation of the brainstorming is having these 40-50 experts at one place at the same time. That the major limitation of this is, if we look at the limitations of brainstorming, if we look at limitations of brainstorming, there are two major limitations of brainstorming. One is difficult to have all 40-50 experts at one venue at the same time. That is one limitation of having experts at the same time. Logistics difficulty, that it may not be possible to have all the experts assembled at one place. And second important limitation is because of the ego, etc., the convergence may not come. People have their ego, they may not accept the idea of other experts. So, based on that you may find difficulty in getting the convergence, and all members are having their divergent views, and they are not agreeing with each other despite because of personality issues and other issues. So, but in this market surveys, people are not knowing each other, and you need not to have all these persons together at one place. So, both the limitations are taken care in the market survey. But the limitations of the market survey is maybe a person who is not connected with the issue, like if you are doing a survey of e-vehicles, there may be people who are not having the adequate knowledge, they may also participate, and that may adversely affects the outcome of your survey results. You may get wrong, unreliable results from the survey. So, persons having no knowledge or less knowledge, less knowledge people will participating in the survey. So, that is one of the limitations, that was many times survey results lead to wrong outcome. Less knowledge respondents participate in the survey. So, you have to see that very difficult to find out that. Second is, they may take a very casual approach. They may not take the questionnaire very seriously and tick 555 or 222 or 333 at all the places, and they may not take the survey very seriously, and or they may put at random. If you are asking the questions and you are seeking the response on a 5-point Likert scale, 1, 2, 3, 4, 5, they may just take at random at some places, and within 3-4 minutes they fill all the survey and hand over to you, and you do this analysis, and based on that you come to a conclusion. Obviously, those conclusions are going to be faulty conclusions. So, that is the limitation of this market survey, that there may be a casualness in the response, not seriousness, non seriousness, and there may be people, they are serious, but they do not have the adequate knowledge to respond to your questions. Then based on these two studies, another technique based on brainstorming and market survey, because of their limitations, another technique which is called Delphi technique has been developed. Here what we do is, we are taking the best parts of brainstorming. We are trying to avoid the limitations of brainstorming. We are taking the best part of brainstorming, and we are taking the best part of questionnaire. So, what we do in this is, expert panel is the questionnaire is prepared, but it is not given to the general public. We identify the experts and we send this questionnaire to the experts only. So, in that case the casualness is also taken care, and we know that these people have the adequate knowledge in the domain in which we are asking the feedback. So, that way means that part is taken care. And then it is not one series of question, and secondly, because we are using the questionnaire technique, the ego issue which was there in brainstorming, that will not come into the picture. Logistic issue, all the experts to be at one place, will also be taken care in this particular technique. So, that is the major advantage, and the drawbacks of questionnaire, that is casualness and unrelated person answering it, that is also taken care. So, what we do in Delphi study is, it is a very simple study, but very effective. Large number of Delphi studies are available if we search on our internet resources. So, what we do here is, the step wise, if we say, step 1 is identify the issue which you want to analyze, solve or forecast, or any such thing. It can be environment related issue you want to solve, what is the pollution problem in a city, air pollution, you can want to analyze a certain situation. So, there can be a issue of forecasting, just like in our case forecasting the demand of electric vehicles, okay, or factors which are going to affect the growth of electric vehicles, or what type of government policies are required to enhance the growth of electric vehicle, what is going to be the role of industry associations in improving the growth of electric vehicle, what is the role of universities and research institutions in developing better technologies, battery technologies, etc., in enhancing the demand of electric vehicle. So, these may be certain issues, or what can be the social impact of that on that, or what is the role of environmentalist or policy makers in promoting the sales of electric vehicles, demand of electric vehicles, popularity of electric vehicle, or what type of promotional campaigns should be launched to enhance the demand or the penetration of electric vehicle. So, these are some of the issues which we can take in this Delphi study. So, series of questions we can draw in this questionnaire, and then we can, step 1 is identify the issue which you want to analyze. Let us say our issue in our case is e-vehicle penetration and growth. Okay. Then step 2 is identify the experts. Okay. So, experts can be, as we said in the previous case in brainstorming, they can come from several domains. So, identify, take 5-6 experts from each of the domain, and a total of 50 to 70 experts you can have. In this case, it is a questionnaire technique. So, you may have 70-80 experts also related to that. That is a good enough number. Then you develop the first round of questionnaire. develop the first round of questionnaire. So, in first round of questionnaire, we will ask the question, what type of in your opinion, how far government is promoting the electric vehicles. You may take on a 100-point response. You say that in your opinion, how much government is proactive in promoting the sales of electric vehicles, and you leave a box here, and people will write on a scale of 1 to 100. People will write 70, 90, 10, 20 like this, and then you also ask why you are giving this opinion. If you are writing 70, why? What is the argument? What are the arguments in favor of? What are the arguments in favor of your response? So, leave some space here, some lines space here, so that people can write why they think that government is 70 means they are very active in this. Some people may write 20 or 30 also, they feel that government is not doing enough to promote the electric vehicle. Then you also ask second question can be about how far automobile industry is proactive in manufacturing or taking the projects of electric vehicles. Third question can be around the city governments, how far they are active in developing the charging infrastructure, or how much incentives they are giving in developing the charging infrastructure. So, like this keep on asking the questions, and in the first round. After having the first round, then what we have to do is, let us come here. What we have to do here is, then we can say that in the second round, we will analyze these responses. We will find out the mean and standard deviation, or better is we can find out analyze the as a fourth stage, we can say analyze the responses, and by we can find out mean and standard deviation, but better in this case is if we can find out median and interquartile range. That means basically range, basically the central tendency and the dispersion of the responses, how far these respondents are converging or diverging. Higher the interquartile range, that means they are very divergent. If the interquartile range is small, that means they are converging. So, with this, then you go to the second round of this. To the same experts, you say that in the first round to this particular question, your response was 70, the group median is 55, and these are the arguments given by the respondents. Would you like to revise your response? Now, you are asking would you like to revise your response. Now, in this case, because experts are not knowing each other and you are educating them also by the opinion of the other experts, there are chances that experts will revise their opinion. And most of the time after second round, you get the convergence on these issues. So, once you are having convergence on these issues, or if it is not there, you may go for the third round also. And usually we do not take more than 3 rounds, because if the convergence is not coming after 3 rounds also, then we can take a call, we can conclude that issue is still very immature, people do not have still the very crisp opinion, or they do not have the enough idea, knowledge about how the things are going to happen in the coming years. So, you may wait for another 6 months or 1 year and again conduct this Delphi study. So, this is the kind of a study which is very useful for long term strategic forecasting, for long term strategic projects to be taken based on the opinion of the experts. The technique 4, we have listed 4 techniques initially. You can take the historical analogy and life cycle analysis, though battery vehicles are a new thing, but we can take the analogy of some other products of similar nature which has been launched in the past, and how this item has been taken by the society, and how this item was manufactured, and based on that you can take a call on this. So, that is prediction based on the analysis and comparison with the growth and development of similar products. Forecasting new product growth based on the S curve of introduction, growth and market situation. So, you know that previous product how this has grown. So, based on that you can take the a call on this also. Then comes a few examples from this. Say there are people are trying new methodologies also. Industry people are trying to find out new ways also to have a better forecast. This is a case of Obermeyer, which are in sports products. They are saying they are tying the salesman bonuses with the forecast. They ask the salesman to make a forecast, and if their forecast turns out to be a correct forecast, they will get more incentives. If their forecast is not good, they will get less incentives. So, in this case, you ask them to make a forecast. There are two salesmen, let us say, and let us take this example. So, the forecast has been made by the salesperson. Let us say he has given some objectives and his forecast is matching with that, or he is saying that he has given some objective of 100 units, but he say that I will be sell 150. Objective to him is 100 units and he make a forecast of 150, that I will sell 150. So, his factor is 1.5, but in actual also he is able to achieve 150. Actual divided by objective, actual also he is able to do that. So, he will get 80% additional incentive. He will get 80% additional incentives if he is able to make the his actual sales are matching with the forecasted sales. On the other hand, if we look at it in the same table, suppose he has forecasted only 100 and his objective was also 100, but he was able to make a sales of 150. In both the cases, in the previous case also he was able to make a actual sales of 150. So, his factor is 150, but he has forecasted 100 only, and so his incentive will be only 50% of that. He will earn more 50% over and above his salary, whereas if his forecast is matching with his actual sales is matching with his target, he will get 80% incentives. So, that is the you are giving him a additional incentives if his forecast is matching with his actual performance is matching with the forecast. On the other hand, if we look at it, suppose he has given a target of 2.5, he said his objective is let us take third color also. Suppose his objective is 100 only, but he said that I will sell 250, but in actual he is able to sell only 150. His incentive will be reduced to 20% only, because he is much away from the his projected forecast. He is not able to achieve the forecast. Company has put items etcetera, providing him all the material for 250, but he is able to achieve only 150. So, for the same actual sales, depending upon the forecast, his incentive can vary. If the actual sale is matching with this, incentive is high 80%. If it is lesser than that, if his sales is more than this, then also it is bad. If it is lesser than, then also he will get the lower incentive. So, like this, so we can link the, we can tie the salesman bonuses to their forecast. So, now in this case salesman is performing two activities. One, he is performing the actual sales, at the same time he is helping the company in the forecasting also, and he being very close to the market, he is the best person to make a forecast. This is I explained earlier also. If you are launching a new item, in the initial forecast, your forecast may be too much staggered. You are don't knowing, there is a forecast and actual sales may not match with each other. There is a scattered phenomena, but as the things are improving after a certain period, you may find that forecast and this thing are now starting matching, and after with more time you are finding that now they are exactly matching with each other. So, we have to after 20% of the sales you are finding now you are knowing very clearly, and you are able to make a better forecast, and your sales has started matching with the forecast. And once you are able to sell 80%, that is at the fag end of the season, now you are very sure and your forecast is much more accurate. This we have already talked about. Just to recap that some of the implementation aspects. So, our forecast can be short range, it can be medium range, it can be long range, less than 3 months. As I said, this is 3 months to 1 year, or some literature say 3 years. This is more than 1 year, more than 3 years, more than 5 years. Time is again depends upon the decision maker. And this is used for planning, purchasing, job scheduling, workforce level, job assignment, production level, inventory, etc. The short range is required for that, whereas medium range is required for sales planning, production planning, budgeting, analyzing various operating plans, whereas long range is required for capital expenditure, whether you enhance the facility, whether you set up more facilities, facility location, expansion, and research and development purpose. How to integrate the forecasting and production? You take the previous year's data, based on that use the forecasting models and make a forecast of next 12 months. And then brand and product manager, you can take the subjective judgment of them to review and recommend changes. Based on that you get the revised forecast, and then you can calculate the gross market requirements for next 3 years. And based on that you can develop the average production schedules and allocate the aggregated requirement plans, and then based on that we can do the short term scheduling. So, from the previous last year 3 years data, we can project next 12 months of forecast. These are some of the factors which affects the demand forecasting. We can take leading indicators also. It can be coming from the social media, it can be coming from the technology people, it can be coming from the government policies also. So, we can we should be very careful in watching the trends in the industry, trends in the government policies, global trends also, to incorporate that in our forecasting model. Then there is some coincidental indicators like growth in GDP and other some changes happening in the society, so or in the economics, that we can keep, or there may be some change in the demand of the people. There can be lagging indicator which has already happened, like your previous year data, you can consider that. Then you can also look at the internal factor, what is happening within your factory, what R&D people are doing, if they are changing some material, if they are working on reducing the cost of the products, or if there is a government, your company has a policy of sales promotion, or if they are having expanding to new geographies or new markets, that will also you have to consider. So, while designing the forecasting system, we have to see what is going to be my level of aggregation, and what is going to be my unit of measurement, whether I am going to measure individual brand, color and fine details, or I will aggregate at a model level, or I will have a total aggregation. Then I have to decide time horizon, whether my forecast is required for a short time horizon or medium range or long range, depending upon the purpose, depending upon the decision at hand. And also based on that we will decide the forecasting technique, based on level of aggregation, unit of measurement and time horizon, and the purpose of the forecasting, we can decide the forecasting technique. So, role of demand forecasting is there in the business strategy also. Based on the forecasting, long term forecast, you can decide your growth strategy, how you are going to grow in the coming years with the help of mergers and acquisitions, or you know that this particular sector is going to grow. So, based on that you can also decide the portfolio, what type of product portfolio you should have in your business strategy, or you can use the BCG metrics also with the along with the forecasting and BCG metrics, depending upon how much resources you are having. So, you can decide the portfolio also. Positioning strategy also, how to position your products based on the various P's which we are knowing in positioning strategy. So, based on that, based on price, based on promotions, and you can decide on that. And investment strategy also, whether you should invest in more capacity expansion, or in R&D, or in new product development, or in market penetration. So, all these major decisions of business strategy depends upon the forecasting. So, friends, in this unit we have studied the importance of demand forecasting both for strategic decision, business strategy decision as well as for operational level decision. We studied broadly two sets of techniques. One is quantitative techniques and then the qualitative techniques. In quantitative techniques we have studied time series models and the causal models. And again it is both science and art. You have to see that what is the right forecasting technique for me and how much I should depend upon that outcome of that forecast. I may superimpose certain other subjective parameters after applying that technique based on my judgment, based on the knowledge, based on the opinion of the other experts, etc. I can further strengthen. And second important point we have to keep in mind, forecasting is not a one time affair. Even after forecasting for the next 6 months or this, you should keep on revising your forecast based on the actual data coming, actual information coming. As you proceed with your sales, you are finding that more information is coming, and based on that you keep on revising your forecast. That we have seen in case of this fashion item case. As the 20% sales happened, you are now much better in forecast. When 80% sales happened, your now forecast is almost matching with the actual demand. So, these are some fine points of this demand forecasting, but a basic input to any planning process. So, with this we close this unit, and thank you very much.